Hello everyone. In our last class, we discussed lab activity and how to do the activity and how to write in examination point of view. And there we get the different types of images with a concave mirror when object is arranged in different places, in various places. If changing the position of the object, the image, position and as well as characteristics also changed, right? That we can able to represent by the ray diagram. Okay, then here we have a ray diagram definition. See that ray diagram means a ray diagram is a diagram that traces the path that light takes in order for a person to view a point on the image of an object, right? By the ray diagram we can able to know the position of the object and position of the image, right? And while seeing that ray diagram we can able to judge the characteristics of image also. Okay, now we are going to discuss about the ray diagram, right? And in our last class we drawn one ray diagram. If object is at infinity, the image is formed at focus, right? Then we can able to draw the ray diagram if object is bring near to the mirror. Now object at infinity, no, right? If object is on the principal axis of the curved mirror, then we can able to draw the ray diagram or not. Now we are going to discuss. Then this is concave mirror, right? If a principal axis, pole, focus, center of curvature, I kept object on the focus, behind the center of curvature. We kept the object at beyond the center of curvature, right? And before a ray diagram in our previous class we discussed object at infinity. Here object is here, right? How to draw the ray diagram if object on the principal axis, right? Here while drawing the ray diagram, here we have to follow one simple instruction. We should take minimum or at least 2 rays should emit from the same point. While drawing the ray diagram, take 2 rays or emitted from same point, right? And one more, the 2 rays we have to take from same point in different directions. Okay, right? For example, this is one ray and here one ray, isn't it? The 2 rays are emitted from the same point, right? First rule what? While drawing the ray diagram, we have to take at least 2 rays that should be emitted from the same point. From here I am going to draw, no, from this point I have to take 2 points. We have to take 2 points from the same point. And one more condition, the 2 rays should travel in different direction. Have understood our first condition? We have to take minimum 2 rays from the same point, right? And the 2 rays should travel in different direction, right? After the reflection, after the striking the concave mirror, they reflect. Okay, they reflected. These are reflector rays, right? Where, at what point the image is formed? At what point the image of the given object is formed? Obviously we know that the point of intersection of the rays, the point of intersection of a reflector rays, not incident rays. Have understood? Very simple now. Then we have to take at least 2 rays from the same point. The 2 rays should travel in different direction, and after the reflection the image is formed the converging point of or intersecting point of reflected rays. Here the sharp image is formed. Here the sharp image is formed. Have understood or not? Here the image is formed of object 2. So where we should keep the screen? At A. Right. Here one doubt. What happened if we move the screen before or behind the point A? Right. From this ray diagram we came to know that the sharp image is formed at point of A. Then question is, what happened if a screen is moves before or after the point A? What happened to the image? If I keep the screen here at point B, for example, see here image is formed by the intersecting of 2 rays, 2 reflector rays. Here what happened? Here image is formed. Here one image is formed. Here one image is formed. Then here on ray, then ray is intersecting the screen at different points. No, due to that different images is formed or not? Right. If you take n number of rays, for example, all right, then I have taken one more ray which is emitted from the same point, right? Then here it pause, here it is intersect, and one more ray is intersect here, right? Have understood or not? Then in the different points it is intersecting, right? So due to that reason the image is formed blur, right? If we arrange the screen before or behind, if we arrange the screen before or behind the point A, it gives blur image. If at point A, if you arrange the screen at point A, we get a sharp image. Why? Because all reflector rays are converging. All reflectors are converging. Here due to overlapping of the images, then it gives blur image. Finally it gives blur image. Get it? Then this is. And here it is a little bit difficult thing to find. Always to find out the angle of incident, angle of reflection. Here we drawn this reflector rays based on the laws of reflection, right? What is the laws of reflection? Angle of incident equal to angle of reflection. Angle of incident equal to angle of reflection, right? If every time if I keep the object here and then different cases, in every case to draw the angle of incident, to find the angle of incident, angle of reflection, it is difficult thing or not? To find the angle of incident, angle of reflection, we have to draw the normal at point of incident. It is a little bit a different thing, no? So is there any, to overcome this problem, is there any simple way to draw the ray diagram, right? From based on this total observation, we get the simple way to draw the ray diagram. Here we have some rules. If you follow the rules, it makes easy to draw the ray diagrams, right? Now we are going to discuss rules to obtain the image by the spherical mirrors. Sorry. Right. Rules to obtain the images by spherical mirrors. Spherical mirrors means again two are there now, concave and convex. Then these rules are same for concave and convex, but I will explain separately concave mirror and convex mirror. And here we are going to discuss in the case of concave mirror. Have understood or not? These rules will help us to draw the ray diagram in a simple manner, right? Why? Because always to find the angle of incident and angle of reflection and drawing the normal at point of incident for the given incident rays, it is little bit difficult thing, right? Then here we are going to write first rule, rule 1, or otherwise ray 1, whatever it may be, right? Rule 1 is the incident ray pass parallel to the principal axis okay, incident ray is pass parallel to the principal axis. After reflection, it pass through focus. Get it? If incident ray pass parallel to the principal axis, after reflection it pass through the focus, right? Then while drawing the ray diagram, then simple, then concave mirror. Here I am explaining with the concave mirror, no? Then I will take concave mirror and a principal axis. Always whenever you are drawing the ray diagrams, always you have to identify all the terms what we discussed. You have to draw the principal axis and you have to identify the pole on the mirror and you have to identify the focus and center of curvature on principal axis. Okay, right. Here what is our rule 1? Incident ray pass parallel to the principal axis. Which is the principal axis? This is the principal axis, right? Then incident ray is pass parallel to the principal axis. This arrow mark is indicates the direction of ray of light, right? The ray of light is passing towards the mirror. Now this is incident on the mirror, no, right? This ray is incident on the mirror, so that's why it is incident ray, right? The incident ray is passed parallel to the principal axis. After the reflection, it passes through the focus. Easy rule or not? Easy rule. While drawing the ray diagram, we will take at least 2 rays, no? In that one, out of 1 ray is simple to identify. If incident ray is passed parallel to the principal axis, then reflector ray is passed through the focus. This is first rule. Okay, right. Then here this is reflector ray. Right. Then this is incident ray. Here what is our rule? Incident ray pass parallel to the principal axis. Incident ray is passed parallel to the principal axis. After reflection, it passes through the focus. Rule number 1. Now here we are going to discuss rule number 2. Second rule. Second rule. Rule number 2. If in rule number 2, if incident ray pass through focus after reflection, it travels parallel to the principal axis. Get it? Right? Quite opposite to previous rule. First rule, incident ray is parallel, reflector pass through the focus. Here, quite opposite to it, incident ray is passed through the focus. Now, this becomes incident ray. Or better, I will draw once again. Right? What is our rule? Second rule is, if a incident ray pass through the focus, after reflection, incident ray pass through focus, incident rays pass through focus. After reflection, it travels, what? Reflected ray travels parallel to the principal axis. This is the principal axis, so it is pass parallel. This is second rule. Is it easy or not? This is reflected ray, RR, right? This is incident ray. IR means incident ray, not infrared rays. RR means not Rajamouli's movie, right? RR, reflected ray. Okay, the next rule number 3. Get it? First rule is very simple. If incident ray is passed parallel to the principal axis, after reflection it pass through the focus. Second ray, if incident ray is passed through the focus, after reflection it travel parallel to the principal axis, right? Then next one, rule number 3. Rule 3, if incident ray pass through the center of curvature, after reflection, it comes back in the same direction or same path, right? After reflection it comes in the same direction, or otherwise retraces same path, or otherwise we will use one more, retraces the same path. In the sense it passes through the reflector. Then here you can represent with the help of the diagram: concave mirror, principal axis, pose, focus, center of curvature. Here I said incident rays pass through the focus, right? Sorry. Then third ray, if incident rays pass through the center of curvature, after reflection it retraces in the same path, or it reflects back, right? Haven't it? Very easy, right? It travels through the center of curvature, and after the reflection it comes in the same direction. It never changes its path. Have understood? This is third ray. Rule number 1, rule number 2, rule number 3. Now we are going to discuss rule number 4. Rule number 4. Rule number 4 is, if incident ray is fall on the pole, right? If incident ray is fall on the pole, after the reflection it follows the laws of reflection. Sir, you said just before, to laws of reflection means again at the point of incident we have to draw the normal. No, here no need to draw the normal again. Why? Because the incident ray is falls at the pole. Then the pole is act as a point of incident. Then here we have a principal axis. This principal axis is act as normal to it. The principal axis is act as normal to it. Then this is angle of incident. Then after reflection it passes then here it follows laws of reflection, I equal to R. This is fourth ray or fourth rule. Have understood or not? Here we have 4 rules to draw the ray diagrams with a spherical mirror. Very important rays. You have to remember it, you have to by-heart it. Why? Because then in our next class we will discuss the ray diagrams of in various position of the object. In that, while drawing the ray diagrams, out of these 4 rays we will use any 2. So try to by-heart today, right? Then once again I will repeat that. Then rule 1, if incident ray is passed parallel to the principal axis, after reflection it passes through the focus. Rule 2 is, if incident ray is passed through the focus, then after reflection it passes parallel to the principal axis. Then third rule, if incident ray passes through the center of curvature, after reflection it retraces the same path. And rule 4, if incident rays fall on the pole, it follows the laws of reflection, right? This is with the concave mirror, right? After convex mirror, right? Now we discuss it with concave mirror. No, next we have to discuss with convex mirror. Rule is same, rules are same, right? But little bit drawing is different. Why? Because the both have dissimilar, then concave and the convex is dissimilar surfaces. No, so that's why drawing also little bit different, right? Then rule 1. Rule 1 is said that if a incident ray is passed parallel to the principal axis, right? Convex mirror, a pole. Here we discussed in our previous class for the concave mirror, center of curvature and focus lies in front of the reflecting surface. But in the case of convex mirror, the focus and the center of curvatures lies behind the reflecting surface, right? What is the first rule? First rule, then if incident ray is passed parallel to the principal axis, parallel to the principal axis. This is convex mirror, no? Then convex mirror is also called as converging mirror, right? Then here the incident ray is diverged, right? Concave mirror is converging mirror, so that's it converges. Here it is diverged, no, it travels. Sir, you said in the rule 1, if a parallel ray is passed, if incident ray is passed parallel to the principal axis, after reflection it travel through the focus. I said no. In this case only little bit change. It is appeared to pass from the focus, right? To complete this ray diagram, we have to extend the reflector ray backward. Then once I compare with the concave mirror, same rule with the concave mirror. Once see, right? Pole, focus, center of curvature. I said incident ray through the focus. In the case of concave, it passes directly through the focus. In case of convex, it appears to pass through the focus, right? This is rule number 1. In case of rule number 2, right? Rule number 2, what is the rule 2? If incident ray pass through the focus, if incident rays pass through the focus, after reflection, reflector ray pass parallel. This is right. This is rule number 2. In case of concave mirror, once I will compare it. In case of concave mirror, very simple. Then incident ray pass through the focus, reflector ray parallel. This is reflector ray, right? This is reflector ray, right? RR. parallel or not, or are parallel or not, right? This is rule 2. Next, rule 3. Rule 3. In rule 3, if incident ray is passed through the center of curvature, after reflection, it retraces the same path. It retraces the same path. It retraces the same path. Then, like this. This is rule number 3. In case of concave mirrors, right? Then here you can take an SC, right? Like this we have to represent it, right? Then last one, rule number 4 with the convex mirror. Rule number 4 with convex mirror, right? What is the rule number 4? If incident ray falls on the pole, if incident ray fall on the pole, here it follows laws of reflection, then it reflects in this direction, it is on. Have understood or not? Right? Here the principal axis only act as a normal. These are the 4 rules. These 4 rules are very, very, very important. Then today I had these rules. In our next class, we will learn how to draw the ray diagrams. Then to all the ray diagrams, to draw that all ray diagrams, we follow these 4 rules only. By the following of these 4 rules, we will draw the ray diagrams. Okay, thank you.